However, this statement does not imply that horizontal curves with a radii in excess of 1,000 meters are always safe, since the phenomena of risk adaptation, whereby drivers concentrate less and drive at a higher speed on section of the major urban road they consider to be safe, should be taken into account. What do you need to focus your design on? The focus of design measures should be primarily on improving roadside safety through the roadside hazard management by design and provision of appropriate recovery and protection measures. The effectiveness of roadside features depends greatly on 5 aspects. Knowledge of the safety characteristics and limitations of roadside features by the designer, the correct choice of appropriate treatment, the correct installation of the roadside safety features, the maintenance of roadside safety features, and a regular monitoring of installations to ensure they perform adequately. There are 2 needs that are the key to effective attention to safety in a roadside design process. The first one, the need for explicit evaluation of design trades-off with an impact on road safety. The traditional design process, attention to safety has usually been implicit, not explicit. The common myth amongst designers is that if the current standards are met, then the road is safe. The reality is that the road design standards are often more than a limit. One should not provide less than the standard stipulates, but within the limits, to provide more is often better. Therefore, just meeting the standard does not mean that an appropriate amount of safety has been provided. The second principle, the need to recognize that the design of the roadside environment is highly complex and probabilistic process. There are many levels and interactions between the different roadside design components, between roadside elements and other aspects of the facility design, and between the road itself, the driver and the vehicle. As a result, information touching on road design issues necessarily is available from many sources. The design of roadside environment is a complex problem. Evaluation of alternative designs and choosing between them are difficult tasks, which involves degree of uncertainty with respect to occurrence of crashes, the outcome of crashes in terms of severity, the real cost of the property damaged, injuries, and fatalities which can result. Obviously, before producing any design on a major urban roads, you should familiarize yourself with the crash statistics. They should be available from the road agencies, and they should be taken into account when producing a design of major urban roads. Nonetheless, such analysis, which provide an explicit framework for considering design trades-off, is a much more desirable approach to roadside safety design than meeting arbitrary standards that underpinning may or may not be appropriate to a given situation. The process is generally based on 2 fundamentals models. Predictive models that provide a way estimating collision frequencies and severities under a wide variety of conditions, and a cost effectiveness models that provide a way of quantifying the life cycle cost and the benefits associated with any given set of safety measures. Predictive models have been developed and deployed by a number of agencies around the world. You should be aware that the state of the art in this area is continually developing, and you should be monitoring regularly for new models and techniques which may have applications to your design challenge. Road safety orders. First developed in Australia and New Zealand, and in the UK, this process specifically investigates the roadside safety of a particular project that has a proven potential to improve the safety of both proposed and existing facilities. Road safety audits, especially during the design stage, create the opportunity to eliminate, as far as possible, road safety problems in the presence of the new road project. They should be seen, however, as a part of broader scope of philosophy of roadside hazard management. A road safety audit is a formal examination of any road projects which interacts with the road users, in which a qualified independent examiner reports on the project's accidents, potential, and safety performance. The audit may be conducted at the project's feasibility stage, concept design stage, detailed design stage, pre-opening stage, and on the existing roads. The earlier a road is audited within the design and development process, the better. Roadside hazards and a clear zone concept. Research has shown that in 50% of all run-off roadside accidents, the vehicle leaves the road in a skidding manner. Roadside hazards can significantly increase the severity of crashes, and it is necessary to manage roadside hazards in such a manner as to decrease the severity of these crashes. The process has got a number of steps. There is 7 steps. The step number 1 considers a risk assessment of the roadside hazards. The step number 2, consider removal or redesign. Removal of the roadside hazard or redesign the road cross section to allow for safer conditions. If this is not possible, you should go to the step 3. Consider relocation of the roadside hazard to a position where it is likely to be hit by an errant vehicle, less likely to be hit by the errant vehicle. If that is not possible, you should consider the 4th step. Consider a breakaway device. That device should be used to reduce impact of severity. If this space that is available for device is not available, okay, you should consider the 5th step. Consider installation of a traffic barrier systems. Shield the roadside hazard with an appropriate traffic barrier. If for whatever reason the barrier is not suitable, or the space is not available, or it is costly, you should consider delineation. Provide delineation to increase the awareness of the presence of roadside hazard. And the step number 7, if none of the above treatments will reduce accident severity, leave the road hazard as is, because the installation of the road safety barriers or any other features may be the hazard of itself. Common existing road hazards include trees, supports and poles for street lighting, utility services, signage, drainage structures such as culverts, drains, drop inlets, bridge abutment and piers, side slopes such as embankments, ends of traffic barriers, bridge railing, incorrectly positioned traffic barriers, less than within the 3 meters of the roadway, and fire hydrants. It is not feasible to provide sufficient width adjacent to the carriageway that will allow all all errant vehicles to recover. Therefore, it is necessary to reach a compromise or level of risk management. The most widely accepted form of risk management for roadside hazards is a clear zone concept. The clear zone, it has a horizontal width measured from the edge of the traffic lane that is kept free of hazards to allow an errant vehicle to recover. The clear zone is a compromise between a recovery area for every errant vehicle, the cost of providing that area, and the probability of the errant vehicle encountering the hazard. It is an adequate roadside width for 80% of road from errant motorists to be able to regain control of their vehicles. The clear zone should be kept free of non-fragile hazards where economically possible. Alternatively, hazards within the clear zone should be protected. The clear zone width depends on speed, traffic volumes, side slope, and horizontal geometry. It should be noted that the clear zone width is not a magical number, and where possible, hazards beyond the desirable clear zone should be minimized. Clear zone widths vary throughout the world depending on the land availability and the design policies. The clear zone with a width varies between 4 to 10 meters, with the upper end of the scale of being appropriate for the high-speed roads within the urban area. More recent studies have shown that the first 4 to 5 meters provide most of the potential benefits within the clear zone. In an urban lower speed environment, it can be difficult to achieve a 3 meters clear zone. Existing hazards are often within a clear zone and can be expensive or socially sensitive to relocate. Aesthetics and urban design considerations should become more predominant, and it is the role of the road designer to determine an appropriate compromise. In these situations, it may be appropriate to accept a reduced clear zone of 1 meter to balance the competing community needs. A clear zone of less than 1 meter is not desirable. Where non-fragile objects are located within the clear zone, consideration should be given to protecting these hazards. The greenfield sites in a lower speed environment, a clear zone of 3 to 4 meters should always be considered. The clear zone concept is widely accepted. However, the most appropriate width for the various road conditions is constantly debated amongst practitioners. The clear zone falls within an area called the recovery zone. The recovery zone is the total unobstructed area available along the edge of the road, and by convention, it is measured from the edge of the closest traffic lane. The recovery zone may have been recoverable slopes, non-recoverable slopes, and a clear run-out area.